Welcome to part 2 of Zombies and Reinforcement Learning. In this video, we're going to go ahead and start working on our characters, our player and our zombies. So, let's go ahead. We're going to need random. We're going to need Pygame. We're going to need math, not map, math. And we're going to say from util import star, and we don't have util yet, but in fact, let's go ahead and code out util. We're going to need that in this one, so let's just put it together. So these were just kind of general get and check collision methods. You know, in Pygame, you're not going to, it's not like there's anything in the game engine, at least nothing I've seen, that naturally recognizes that what you're putting together is an object that shouldn't be run into. It's going to help you throw your graphics on the screen, but it doesn't care if they, you know, flow into each other. So we need a way to check for collisions. That's checking for collisions if your player is running into walls. That's checking for collisions if you have a bullet hit a zombie or a zombie hit the player, or lots of reasons to need to do a collision check. So we're just going to say check collision rect and rect list. Everything in here is a rectangle. For I in rect list, if rect dot collide rect I, then return true. Otherwise, return false if none of them hit. And then here, we're going to go down to the bottom, and we're just going to copy paste that. Copy paste our check collision. And in this scenario, we're not trying to return whether or not something collided. We're just returning, we're going to do get collision. So we want to return the actual collision here. So we're going to return none if nothing fits. And then I'll just remove one of those extra lines. All right, so we now have a check collision and a get collision. And we'll frequently use those two together. We will use this to see if there are any collisions, and then we'll immediately use this if we need to get the actual value to pull back what that collision was. All right, so we've got that. Now here on back under character Py, we're going to define a class player and an init method that includes self. It's going to include world width, world height, and walls. And then we'll go ahead and start declaring some of our player variables. So we'll need self.size equals 50. We're going to say our player is 50 pixels wide. Self.speed is equal to 5. The self.rect, which is where is our player, self.x equals world height divided by 2, self.y equals world, and actually, hang on, this one should have been self.width and self_height divided by 2. All right, so what this is doing is this is basically saying that self.x, self.y, the x-y coordinates, so our player, are going to be right in the middle of the screen. You could put the player anywhere, as long as it's somewhere in the world dimensions, but we're just going to say right in the middle. And then we're going to say while true, self.rect, And this is a bit of code I wrote because I was having trouble with the player appearing, in a wall or on a wall. So I'm basically saying pygame.rect self.x self.y self.size self.size. By the way, this is your starting x position, your starting y position, and then this is defining, a square that the player is sitting in, which is why you've got self.size twice. We're going to do if check collision self.rect with walls. So we do need walls in order to define our player. Self.x plus equals random.randint -5 5, and I will do the same with self.y, else break. So what we're basically saying here is sit here in loop and give the player a starting position in the middle of the screen, and then wobble that starting position until you find a spot with no walls. And that was an easy way for me to not have to worry as much about the player landing on a wall as I moved the walls around and played with things. So we're also going to go ahead and say self.score is equal to 0. We have no score starting out. Self.ammo is equal to 10. Self.health is equal to 5. Self.images, that's going to be a dictionary. And then we will go ahead and pull our images in. So for direction in up, down, left, right, image equals pygame.image.load images/player direction.png. And then we're going to say self.images direction equals pygame.transform.scale image self.size self.size. And then finally self.direction equals up to start with. So let's talk about what we just did here. Obviously we placed our player in the world. This is basically going to start with our list of directions here. It's going to loop through and it's going to create a dictionary of images where you can pass in up, down, left, right, and get back an actual image object that is, a Pygame image object scaled to the size that we put up here for our player, a 50 by 50 image. You'll notice in the images folder here, if you go into player up or player right, you've got your player here that is going to be, facing whatever direction. She's a fairly large image, or shows up that way in VS Code, not actually all that large. But yeah, so we're basically going to pull in, player up, player right, player left, so that we can display those views on the screen. And then we also have our zombie right, left, up, down images. And if you're curious, these are all AI generated. I am not capable of artwork. If this is the kind of thing you find fun, then you could put together your own completely custom images for zombies pointing left, right, up, and down, and your player pointing whichever direction you want her pointed. All right, let's go back to our character's pie. Now we need a draw method. I wanted the players, or I wanted the different characters to understand how to draw themselves. So we're going to say draw self screen camera X, camera Y, screen.blit, self.images, self.direction, and then we're going to say self.x minus camera X, self.y minus camera Y, and that is done for that one. All right, let's go look at our zombie now. So we're going to say class zombie, def init as always, and that's going to be self, world width, world height, size equals 50, speed equals 1. Okay. And let's see if there's anything we can, not enough we can copy. All right, we're going to say self.size equals size, self.world width equals world width, self.world height equals world height, self.speed equals speed. That changes as the levels go on, of course. Self.x, self.y equals self.spawn, because we want our zombies to be able to spawn in various portions of the map, although they'll always be around the edges. We'll do something very similar to what we did here. So I'm going to go ahead and grab the next few lines here. And then instead of player, we're going to say zombie. But otherwise, these are the same. We've got a self.images, we've got a for direction, and we're going to grab, our directions. And then we will also go ahead and say self.direction out of the box is going to be up. And then self.rect equals Pygame dot rect 0, 0. Self.size, self.size. And then we'll say self.rect.center equals self.x, self.y. Okay. Now we need a spawn method to say where our zombie is going to spawn. So we're going to say def spawn is self. Spawn positions equals, we'll do, and this is, we're going to have a whole bunch of randomness here. So we're going to say random.randint 0 self.worldWidth minus self.size 0. So that's our top edge. And then we're going to have random.randint 0 self.worldWidth minus self.size self.worldHeight minus self.size. Okay. Bottom edge. And then we're going to say 0 random.randint 0 self.worldHeight minus self.size. And we're basically defining the edges of the environment. And then self.worldWidth minus self.size random.rand int 0 self.world height minus self.size. Okay. And then we're just going to return random. So we've basically created, you know, a matrix of positions around the edges. And then we're just going to return random.choice spawn positions. So every time a zombie spawns, we're going to pick a random position from one of the edges of the map, and we're going to spawn the zombie from that location. That is our target here. That's what we're doing. So let's go ahead and code our, we get to some of the, well, let's do our draw method. We'll need that. So, and then really our draw method can be, let's see, do we even need to change anything? I don't think we do. I think the draw method is going to be identical to what it was with our player. All right, now we need to actually build in some basic intelligence for our zombies. We're not going to make our zombies AI driven. The player is going to be AI driven. The zombies will follow just some basic movement logic. So we're going to call it move towards player. So def, and if you think about it in zombie movie terms, they're never very smart, right? Your zombies are just running after the humans in the scenario. So that's what we're doing here. So we're going to say move toward player, self, player X, player Y, and walls. Okay. So we're going to say dx dy is going to be player X minus self.x, player Y minus self.y. So that's giving us the distance between the zombie's position and the player's position. The zombies have an advantage here. They always know where the player is. We're going to do distance equals math dot hypotenuse dx dy. If distance is not equal to 0, then we're going to do some normalization. dy equals dx divided by distance, dy divided by distance. Okay, and then we're going to try a couple of different methods of movement. So we're going to try horizontal movement first. So we're going to say new x equals self.x plus dx times self.speed. New rect equals pygame dot rect, new x self.y, self.size, self.size. Can move x equals not check collision new rect walls. So let's talk about what we're doing here. So we are attempting to move our zombie along the x-axis towards the player. We're declaring a new rectangle that's in the new position. We're declaring it to move to the new x with the existing y and the current size. We're then validating that that's an okay move. So we've kind of created a temporary, and you'll see this used in other places in this code. We're creating a temporary new rectangle for the new position. We're moving it towards the player, and then, or moving it towards whatever the objective is. And then we're going to see if that was valid, and if so, then we set it to, the new position. So we're going to go ahead and say if can move x, self.x equals new x, else we're going to go ahead and do new y equals self.y plus dx or dy times self.speed, and then we're actually going to multiply it by 1.5, and what we're trying to do here is increase speed along y-axis if horizontal movement is blocked. So why are we doing that? This was one I just kind of found through experimentation. If I just used a basic, move towards player X, move towards player Y type of logic and did not include this, then zombies would stop at a wall. They would basically run into a wall and then move incredibly slowly towards the player. They would still get there. They would just have a really hard time creeping along the wall. So this is an attempt to say, hey, if you hit a wall, be a little bit more aggressive in that y-axis movement until you get free, basically. So here we're going to say new rect equals pygame dot rect self.x new y self.size self.size. Okay. If not, check collision. New rect walls. Then we're going to go ahead and do self.y equals new y. All right. Finally, we're going to say new y equals self.y plus dy times self.speed. Oh, that needs to come in one. Okay, we're going to say try vertical movement next. And same kind of deal here. So we're going to say new y equals self.y plus dy. Oh, we already did that. Sorry. We're going to say new rect equals pygame dot rect self.x new y self.size self.size. We're going to do the same kind of logic. Can move y equals not check collision new rect walls, and then we're going to say if can move y self.y equals new y else, and now we're going to increase speed along x axis if the vertical movement is blocked. So same kind of logic. In a world with no walls, this logic would not be necessary. This is because we, again, needed the zombies to be able to climb over walls when they needed to, or get around walls more quickly. Self.x plus dx times self.speed times 1.5. New rect equals pygame dot rect new x self.y self.size self.size. Okay. If not, check collision new rect walls, then self.x equals new x. Okay. We will go ahead and update position and direction. So we'll go ahead and say self.rect.top left equals self.x self.y. And then we will go ahead and set the zombie's direction based on movement. So we didn't have to do this for the player because the player's direction is going to be easy. You'll have some kind of input. You're going to say, go left, and then the direction will move. The zombie, we're defining this programmatically. We're defining a new direction based on the player's location. So we need to actually show which way it's going. Otherwise, you just end up with, a static zombie image. If ABS dx greater than ABS dy, so we're basically saying what was the larger motion. We'll say if dx is greater than 0, then self.direction equals right, else self.direction equals left. And then we'll throw an else in here for if dy is greater than 0, then self.direction equals down, else self.direction equals up. All right, and then assuming no typos, we are done with our zombie class and our player class. I think that's a really good place to just go ahead and stop the video. You've got your zombie, you've got your player. In the next video, we will come back over to the main loop and start to integrate some of these components. Again, there's a lot more code to write, but we're making great progress here. So see you in the next video.